3 into 10 to the power of minus 19. So this is for one photon. This is n photons per second. So n into 3 into 10 to the power of minus 19 will give you energy per second. But energy per second is given to be 6 into 10 to the power of minus 3. From here, we can come to the end. You know the photoelectric equation, kinetic energy maximum is equal to h nu minus. Then kinetic energy is 0 means, it means that h nu is equal to work function. H nu is equal to kinetic energy is 0. Just not emitted. So one twist appear here, two radiations are incident. So one having maximum kinetic energy will be caused having one having maximum frequency. Let us start with the first question. First question on the board. Number of photons of equal energy emitted per second by 6 milliwatts laser operating at 663 nanometer. You have to calculate the number of. So, explanation is given very clearly. Energy of a photon, we know hc by lambda. hc by lambda. Yes, hk written, c written, lambda written. Correct? With proper units. Yes. Now, you know, this is the energy of one photon. If n photons are emitted, and this is coming to be 3.3 into 10 to the power of minus 19 joules. And power means energy liberated per second, energy liberated. That is given to be 6 into 10 to the power of minus 3 joule per second. We want the number of photons emitted per second. One photon's energy we calculated to be 3 into 10 to the power of minus 19. Let n photons are emitted per second. So total energy will be what? N into that one step I am writing 3 into 10 to the power of minus 19. So this is for one photon. This is n photons per second. So n into 3 into 10 to the power of minus 19 will give you energy per second. But energy per second is given to be 6 into 10 to the power of minus 3. From here, we can come to the end. That is P divided by E. That comes to be 2 into 10 to the power of 16. Your answer is coming to be option 2. Okay? Very easy question, commonly asked question. Other one, ratio of the De-Broglie wavelength of a neutron of kinetic energy E to that of a alpha particle of kinetic energy 2E is n is to 1. So it's an easy question. De-Broglie wavelength in terms of energy. I'm not going to explanation part. Lambda is equal to h by in terms of energy. So we have 2 into mass into energy. Now we have to compare the ratio of deuteron. So lambda deuteron will be h by root of mass of deuteron. We can take it to be 2. Energy is given to be E. Lambda alpha particle h divided by root of 2. M is 4. In terms of 4, I am writing 4 only because we are comparing into 4E is into energy is given to be how many? 2E. Okay. Then lambda deuteron divided by lambda alpha, cross multiplying h by root of 2 into 2, 2 into 2 into E. Here root of this is 16. This is coming to be 2 into 4 into 2E. That comes to be 16E divided by H. H is it cancel. Lambda D divided by lambda alpha is equal to root of 16 by 4, root of 4. That comes to be 2. The ratio is coming to be 2. Answer is 2. Okay. Now let us go to the, so explanation I avoided. You can directly get the answer. The third one, when a light of given wavelength falls on a metallic surface, stopping potential is 3.2. Second light is having a wavelength twice the first wavelength is used. Of course, wavelength more, energy less, then stopping potential also will be decreasing to 0.7. Wavelength to the first light is used. So we can easily do the problem from explanation. Okay, then we have stopping potential E into stopping potential is at C by lambda minus V. So first case, it is given to be 3.2 E. Okay, we need no need of writing E because we are comparing it. We can avoid writing 3.2 into V. Systematically we write it. Yes, first case. Second case, it is 0.7. 0.7 E into HC by lambda. 0.7 into HT by lambda, second case. Then we have to get what? Wavelength. Lambda we have to get, we have to eliminate work function. Phi is to be eliminated, lambda is to be retained. So what we are doing? We subtract it. So phi has got, so 3.2 E minus 0.7 HC by lambda by HC minus 2 lambda. This is coming to be 2.5 E HC by 2 lambda. 1 by lambda minus 1 by 2 lambda is 1 by 2 lambda. Now, from here we have to get, now lambda is equal to H into C 6.63 into 10 to the power of minus 34, substituting and finally solving out. The wavelength is coming to be 2.48 into 10 to the power of minus 7. That's coming to be nearly 2.5 into 10 to the power of minus 7. So answer is 2.5 into 10 to the power of minus 7. That comes to be option 2. We go to the next question. Then De-Broglie wavelength of oxygen molecule at 27 degree is x into 10 to the power of minus 2. We have to calculate the Boltzmann's constant is the mass of oxygen. Mass of oxygen is going to be 5.31 into 10 to the power of minus 3. You have to calculate that the De-Broglie wavelength is x into 10 to the power of minus 12. X into 10 to the power of minus 12. So we start from De-Broglie wavelength formula, that is h by p, h by momentum, isn't it? So h by p, that is h by mv or h by root of 2me. For a particle, energy E can be given by 3 by 2 kT. So substituting for that, this is coming to be h by root of 2 into m into energy will be 3 by 2 k. K is Boltzmann's constant. Then we are coming to this formula. This from here 2 to get cancelled, we are directly coming here. So how this h by b becomes h by root of 2me. E is replaced as the energy of a particle 3 by 2 kT. So this is coming to be h by root of 3m into kT. Now some mere substitution, everything given in black and white. H 6.6 into 10 to the power of minus 34, root of 3, mass of oxygen is given 5.32, Boltzmann's constant 1.38 10 to the power of, and temperature is 27 degrees, that corresponds. When you work it out, this is coming to be 26 into 10 to the power of minus 12. So here in place of x, who is coming? Nearly 26 is coming. Okay. We go to the next question. Now, light is incident on a metallic plate having a work function 110 10 to the power of minus 20. Produce photoelectrons of zero kinetic energy, angular frequency. So tell me, what is the meaning of zero kinetic energy? Zero kinetic energy means the incident energy is just is equal to work function. Incident energy is just is equal to work function. Okay. So look, you know the photoelectric equation, kinetic energy maximum is equal to h nu minus, then kinetic energy is 0 means, it means that h nu is equal to work function. H nu is equal to kinetic energy is 0, just not emitted. So this is work function. And work function is h nu. H nu we can write work function is equal to, I write here h nu. How the steps came, I am writing nu. Nu is equal to angular frequency divided by 2 pi. Correct? Angular frequency, that is given here, angular frequency divided by 2 pi. Then we want angular frequency. Angular frequency is 2 pi into work function by h. So this is coming to be 2 into pi, we have taken 3.4. Work function is given to be 110 into 10 to the power of minus joule, that is 2.25 divided by h 6.63. When you work it out, this is coming to be nearly 1.04 into 10 to the power of 16. 1.04 into 10 to the power of 16. Answer is coming to be 4. Sixth question. Particle having charge 3 in 10 to the power of minus coulomb, mass 6 into, are accelerated through applying a potential difference of 1.21. Wavelength of the matter waves associated with the particle is alpha into 10 to the power of minus 12. Okay. Again, direct question. We want the De-Broglie wavelength in terms of accelerating potential. Once again, I write it. De-Broglie wavelength in terms of accelerating potential. H by root of 2m into VQ. We have seen 2-3 problems based on that. We have used H by ME, H by root of 2ME, and instead of energy, we have written 3 by 2 KT. Here, instead of E, we are writing VQ. So this is a form of De-Broglie wavelength in terms of accelerating potential. Now, tell me, everything clear? Everything clear? Root of 2m into VQ is separately calculated. That is coming to be 6.6 into 10 to the power of minus 23. Then lambda will be h is 6.6 10 to the power of minus 34. This is coming to be 6.6 in 10 to the power of minus 23. That is coming to be 10 to the power of minus 11. But your option is given to be how much? Alpha into 10 to the power of. So this is 10 to the power of minus 11. We have written as 10 into 10 to the power of minus 12 to bring this format. What is that format? Yes. Alpha into 10 to the power. So who is in place of alpha? In place of alpha is 10 is coming. Okay. Yes. Answer is 10. Now, next question. I go to the explanation along with it. Light of energy 6 into sine 3 into 10 to the power of 15t plus sine 12 into 10 to the power of 15t fall on a metal surface of work function 2.8. Maximum kinetic energy of the photo work function is given. So first of all, we have two angular frequencies. One is 3 into 10 to the power of 15 per second is there. Omega 2 will be 12 into 10 to the power of 15. Both radiations are incident. Both radiations are incident. So surely who will be causing emission more? Surely. So whose effect is to be considered? The one having more angular frequency is to be considered. So that is what 12 into 10 to the power of 15. That will be causing what? Emission of photoelectrons. Okay. Then energy will be, we have to calculate the energy is equal to h nu. But nu we don't have, we have omega. So h nu is given to be h, we want, this is not h omega, we want h nu, h nu. H omega by 2 pi, That is coming to be nearly 12.6 into 10 to the power of minus 19 joules. And when we convert it into electron volt divided by 1.6, so that is coming to be 12.6 into 10 to the power of, that is coming to be nearly 7.8. So we got incident energy is coming to be 7.87 in electron volt, and work function is given to be in what unit? 2.8 electron volt. Therefore, we have to calculate maximum kinetic energy of the photoelectrons emitted. That comes to be h nu minus work function 7.87 minus 2.8. That comes to be 5.07. That is nearly 5.1 electron volt. The option is fourth option. Okay, very direct question. So one twist appear here. Two radiations are incident. So one having maximum kinetic energy will be caused having one having maximum frequency. One is having angular frequency 3 in 10 to the power of. Second is 12 into 10 to the power of 15. Surely one with more frequency will be causing more kinetic energy of emission. So we have to count for that. Second thing, we want energy. Energy, we remember h nu, but here it is omega. So we converted into h into omega by 2 pi. That value is coming to be 12.6, but work function is given in electron volt. We have changed it to electron volt 7.87. Now simple equation, Einstein's formula, that energy of the emitted photoelectrons, maximum energy is equal to 7.87 minus work function is 2.8. We got 5.01, nearly 5.1. Okay.